Now let's look at some practice with naming. Let's start out with writing formulas from the name. So let's write the formulas for. Let's start out with sodium carbonate, aluminum hydroxide, and let's do copper 1 sulfide. So go ahead and pause the slide or pause the lecture and see what you come up with, and we'll go over these. Okay, let's look at sodium carbonate. The first thing we want to do is write down the cation. Sodium always has a positive charge. Carbonate is a polyatomic ion, and that is its formula. Now, one of the things we want to notice is this is +1 and this is -2. So the charges don't cancel out, so we've got to figure out the ratio that's necessary for the positive and -2 cancel out. So basically, we're going to take our charge from our anion, and that's going to be the subscript for our cation. And then we have 1 here, so we don't put 1 in formulas. And this is the correct formula for sodium carbonate. If we look at what the formula tells us, there are 2 sodiums, which gives us a total charge of +2, and there's 1 carbonate, which gives us a total charge of -2. Now notice in the formula the charges are not written anywhere. If you write the charges in a formula, you will have points taken off. The formula has no charges. We do have to write out the charges to figure out the correct ratio, but our final answer should have no charges. Next, let's look at aluminum hydroxide. Aluminum always has a charge of +3, and hydroxide is a polyatomic ion with a -1 charge. It's one of the few polyatomics that end in "ide." Again, we don't have equal and opposite charges, so we've got to figure out the ratio. And we're going to use our little switcheroony thing. So aluminum is 1, because hydroxide has a charge of 1. And then hydroxide is going to be 3. Now, one thing that I want to point out is that if I left it like this, this would not be correct. What this says is I have 1 aluminum, 1 oxygen, and 3 hydrogens. And that's not what I want to say. I want to say that I have 3 hydroxides. So the way that I show I have 3 hydroxides is I use parentheses around my hydroxide. And that means I have 3 hydroxides. If I forget the parentheses, then I'm showing an incorrect formula. So anytime we have, whoops, let me write this down a little bit, more than 1 polyatomic ion in a formula, you must use parentheses. Otherwise, the subscript will make the formula incorrect, because it will only be the subscript for the last element. Okay, so let's double check our charges. Aluminum, we have 1 aluminum, and that's going to be +3, and we have 3 hydroxides, which is -3. So these two cancel one another out. And if you got this, give yourself a big pat on the back. Now let's look at copper 1 sulfide. Copper 1 means I have a copper ion with a +1 charge. And typically we don't write that 1, but if it helps you to write that 1, then please do, if it helps you keep track of your numbers. And then the sulfide is a polyatomic, excuse me, it is a monoatomic. It comes from the atom sulfur, and sulfur is 2 away from the noble gases, and by 2 away I mean 2 columns away, and it always has a charge of -2. So our 2 charges do not cancel one another out. I am going to use the charge of my anion as the subscript for my cation, and I only have a +1 charge there, so that 1 we don't expressly write. So let's check to make sure this makes sense. If I have 2 coppers and each has a +1 charge, my total charge is +2, and if I have 1 sulfide and its charge is -2, then those cancel each other out. So if you got this as your final answer, give yourself 2 pats on the back. Now let's look at writing names from formulas. So let's look at this. How would we name this? Well, what we want to do first is name the cation. Metals have the same name as, metal cations have the same name as their element. Sodium always has a +1 charge, so I don't need to write its charge, and this is a polyatomic ion sulfate. So sodium sulfate is the correct name. And if you were given the name sodium sulfate, this is the formula that you would come up with. Let's look at one where we have to write out, where we have to use a Roman numeral. Okay, so I always start out writing what I know. Cr is chromium, and O is oxide. Now, chromium has a variable charge. It's not alkali metal, it's not alkaline earth, it's not silver, cadmium, zinc, or aluminum. So it has a variable charge, and I've got to figure that out. And I do that based on the charge of my oxide. So my formula says, I have 3 oxides, which gives me a total charge of -6. And I have 2 chromiums, whose charge has got to add up to +6. So the only charge that would work is +3. Whoops, it's a little high. +3 on both. So my answer here is chromium 3 oxide. And I apologize for that little thingy right there. Chromium 3 oxide is the name. Now it just so happens that there's a 3 as a subscript, but this 3 does not have anything to do with the formula except it tells you the charge of the chromium. So you may have a Roman numeral that is not represented at all in the formula, and I'll give you an example of that. Let's look at this. We're going to name our cation first, our anion second, that's sulfide, and then iron has a variable charge, so we've got to figure out its charge. Well, we know that sulfide has a charge of -2 always. So it's a 1-to-1 ratio here. So to cancel out that -2, iron's got to have a +2. So my answer, being the name of this, is iron 2 sulfide. Notice there is not a 2 anywhere in the formula. That 2 merely tells me the charge of my cation. Anions always have the same charge. Anions don't have a variable charge. It is only metals that have a variable charge. So when we have this Roman numeral here, it's always referring to the metal, because anions never change their charge.